Math 1030, section 10.4, adding, subtracting, and dividing radical expressions. So in this case, we're not doing something very new here. Whenever we add or subtract radicals, we're looking for a common radical. 7 square root of 2 plus 8 square root of 2. You would solve this the exact same way you would do 7x plus 8x. Since they are the same, combine them together. So in this case, 7 radical 2 plus 8 radical 2 is 15 radical 2. It cannot be simplified, so we're done with the problem. Here, cube root of 5, cube root of 5, cube root of 5. Now, yes, they are the same, but, well, here we have variables in here. What I can combine right now is this and this. One of these plus 8 of these makes 9 cube root of 5 minus 4x cube root of 5. Now that is correct. If you really wanted to, you could factor out cube root of 5 and do cube root of 5 times 9 minus 4x. Again, that doesn't really matter. We combine what we can. Now notice in the next one we have 6th root of 5x, 6th root of 5x, and cube root of 5x. Because the indexes are different, this is 6th root, this is 3rd root, this is like x, this is like y, we cannot combine them together. We can put these two together. We can say 8 minus 5 makes 3 6th root of 5x plus 4 cube root of 5x. I know it really feels like we should be able to combine those together, but it's not possible because they have different roots. Try out the practice problems. They'll work the same way. Make sure they're the same radical. Square root of 13. Square root of 13 makes 10 square root of 13. Everything is 3rd root of 7, so that's 9 and 12 make 21 cube root of 7 minus 6x cube root of 7. If you really wanted to, you could take out cube root of 7, 21 minus 6x. For the last one, make sure the indexes are the same. These two are the same. 7 minus 2 is 5 4th root of 3x plus 2 3rd root of 3x. Now, if you look at the next problem, 7 square root of 18 plus 5 square root of 8. On the surface, looks like we can't do it because we don't have the same thing. What we need to do is simplify the radical like we did in the previous section. 18 is the same as 9 times 2. 8 is the same as 4 times 2. Square root of 9 is 3, so that's 7 times 3 square root of 2 plus 5 square root of 4 is 2. This stays underneath. 21 square root of 2 plus 10 square root of 2. Now that is something we can simplify. 31 square root of 2. Now, one of the nice things about problems like this is it's all numerical. There's no variables. If I really want to, I can check my work. I can say, calculator, what is 7 square root of 18 plus 5 square root of 8? Some number. Well, if my answer is correct, it should be the same. 31 square root of 2. And we get the same thing, so I know my answer is correct. Part B is similar, but we have variables. 4 square root of 27x minus 8 square root of 12x. Right now, not the same thing. Let's see if we can make them the same. 27 is 9 times 3, don't forget the x, minus 8 square root of, let's do 4 times 3x. Square root of 9 is 3. Square root of 4 is 2. So that's 12 square root of 3x minus 16 square root of 3x, and now they are the same. That's negative 4 square root of 3x. Now this has a variable in it. What if the variable wasn't there? Let me check if 4 square root of 27 minus 8 square root of 12. Oops, I messed that up. 4 square root of 27, get out from under the bracket, minus 8 square root of 12. Negative 4 square root of 3. I get the same thing. Okay, now look at this one. 7 minus 3. 7 radical 3 minus 2 radical 5. Well, there's no way to simplify that. That is simplified. We can try, but sometimes they just don't go. So that's already in simplest form. Try out the practice problems. They'll work out the same way. D, we have 3 square root of 20 plus 5 square root of 45. 20, I can turn into 3 square root of, that's 4 times 5, plus 5 times 9 times 5. Square root of 4 is 2. Square root of 9 is 3. So that's 6 square root of 5 plus 15 square root of 5 is 21 square root of 5. Does it work? Let's check it. 3 square root of 20, 5 square root of 45. Oh, lift out the plus. 3 square root of 20 plus 5 square root of 45. 21 square root of 5. Looks like I did it right. Part E says 3 square root of 12x minus 6 square root of 27x. 12 is 4 times 3, x minus 6 times, that's 9 times 3, x. Square root of 4 is 2. Square root of 9 is 3. That's 6 square root of 3x minus 18 square root of 3x. Again, you can check your answer so long as you leave off the x. 3 square root of 12 minus 6 square root of 27. And this is 6 square root of 3. No, I'm not done with the problem yet. We still have to simplify this. This is negative 12 square root of 3x. Now we can check. Negative 12 square root of 3. There we go. Looks like I did it right. Now the next example you can see, well, we can't do anything because the radicals are not the same. We have a 5 and the 2 cannot simplify, so that's as far as we can go. The next problems will work the same way. We're just looking at a different index. 2 cube root of 16 minus 4 cube root of 54. Now we don't know perfect cubes as well as we do perfect squares, but we know 8 is 2 times 2 times 2. So I can say this is the cube root of 8 times 2 minus 4 cube root of what? 8 and 7. No, that doesn't work. What can we do with 54? Here we go. 54 is 27 times 2. 27, the cube root is 3 times 3 times 3. There we go. This is cube root of 54 times 2. Cube root of 8 is 2. 2 on the outside times another 2. 3 on the inside minus 4 times cube root of 27 is 3 with the 2 left over, which is 4 cube root of 2 minus 12 cube root of 2, and that's something we can do. 4 minus 12 is negative 8 cube root of 2. Okay, now we can check this using the calculator, but we've got to figure out how to do cube root. If you click the math button over here on the left, one of the very first options you're going to see is cube root. So if I select this, you can do cube root of whatever you want. Now, if I want to do a different root, scroll down here to option number 5 where it says root of x. Here you're going to tell it, well, put in the number, let's say it's 5th root, then go to math, then choose the option, and let's say I want to do 5th root of, I don't know, 1,000. There we go. In this case, I have 2 times the cube root of 16 minus 4 cube root of 54. If I did it right, that should be similar to negative 8 cube root of 2. And it looks like it's correct. All right, what's next? 5 cube root of xy squared plus cube root of 8x to the 4th, y to the 5th. Now this is similar to the stuff we did in the previous section on simplifying. Cube root. Well, I can't take the cube root of x and I can't take the cube root of y squared, so I leave it alone. Over here, I can definitely take the cube root of 8. Now this is 4, this is 5. What I want is a multiple of 3. So what I'll do is I'll take some out so that I have 3's. Nothing changes over here. Cube root of 8 we know is 2. Cube root of, let me write this as x cubed times x times y cubed times y squared. And the reason I wrote it that way is so I could get these 3's in there. The cube root of x cubed is simply x. So that's 2x. Cube root of y cubed is y. Everything else stays under xy squared. Now notice we get the same thing. Cube root of xy squared, cube root of xy squared. We can't really add 5 plus 2xy, but I can factor this out and say that's cube root of xy squared times 5 plus 2xy. Which is correct. A lot of times the textbook will write the radical last. So if you look in the solution manual or the back of the book, you might see something like 5 plus 2xy times the cube root of xy squared. Just keep in mind those are the same thing. Okay, what's next? Try out the practice problems using cube root. We have 3 cube root of 24 minus 5 cube root of 81. Cube root of 24 is the same as 8 times 3 minus cube root 81 is 27 times 3. Cube root of 8 is 2, so that's 3 times 2 cube root of 3 minus 5. Cube root of 27 is 3 cube root of 3, which is 10 cube root of 3 minus 15 cube root of 3. 10 minus 15 is negative 5 cube root of 3. Okay. Five cube root of x squared y plus cube root of 27 x to the 5th y to the 4th. Nothing to do over here. Cube root of 27 is 3. I'm going to rewrite x to the 5th as x cubed times x squared again so I can get that 3 in there. And this is y cubed times y. Cube root of x cubed is x. Cube root of y cubed is y. Cube root of x squared y. Just like the one we just did, these are the same. You can factor it out. You can call this 5 plus 3xy times the cube root of x squared y. All right. So what's next? Quotient rule. What the quotient rule says is if you have a radical of a ratio, you can apply it to the top and the bottom. The reverse is also true. If the top and the bottom both have the same index, meaning the same root, you can extend it over both. So what that allows us to do is stuff like this, where we say the cube root of 16 over the cube root of 27. Can't take the cube root of 16, but I can write that as, let's see, 8 and 2. Cube root of 27. Actually, I can do that. It's just 3. Cube root of 8 is 2. That's 2 cube root of 2 over 3. If you really wanted to, you could write that as 2/3 cube root of 2. It means the same thing. Square root. This is the same thing as square root of x squared over square root of 25y to the 6th. Now, you may not necessarily write this step out, but this is how we need to think. Square root of x squared is simply x. Square root of 25 is 5. Square root of y to the 6th is y cubed. And then we're done. Now this next problem. The 4th root of 7y to the 5th over x to the 12th. Well, that's the 4th root of 7y to the 5th over 4th root of x to the 12th. Can't take the 4th root of 7. We can manipulate this y to the 5th. Let's rewrite that as 4th root of 7 times y to the 4th times y over, we can actually go ahead and do the 4th root of x to the 12th. 12 split 4 ways would be x cubed. 4th root of y to the 4th is y, leaving the 7 and y underneath over x cubed. And again, if you really wanted to, you could write this as y over x cubed times the 4th root of y to the of 7y. These things are the same answer, it doesn't matter. All right. Try out the practice problems, it'll work the same way. Here we have cube root of 24 is 8 times 3. Cube root of 125. Cube root of 8 is 2, that's 2. Cube root of 3 over cube root of 125 is 5. So 2 cube root of 3 over 5, or 2/5 cube root of 3. Very similar on this next one. Square root of 9. I'm going to change that to x squared and x over square root of y to the 10th. Square root of 9 is 3. Square root of x squared is x. This stays underneath. Y to the 10th square root, it'll be y to the 5th. And then we're done. One more practice problem. This is cube root of 8. Y to the 7th, I'll change to y to the 6th times y over cube root of x to the 12th. Cube root of 8 is 2. Cube root of y to the 6th is y squared. This stays under there. Cube root of x to the 12th is x to the 4th. Now for the rest of the problems, we're simply working in reverse. We have two separate radicals, which will condense into one. So here I can say this is square root of 28 over x cubed over 6x. And then just treat it like a ratio or a fraction, simplify. That's, divide these by 2, that's 14 over 3. 3 here, 1 here, 3 minus 1 is x squared. Now we can actually take the square root of x squared. Square root of x squared is x. So this is square root of 14 over 3 times x. For the next problem, be careful. You've got this 2 over here, and notice that that 2 is not under the radical. Square root of 45xy over 2 square root of 5. Let me just move the 2 out of the way. Let me just make that 1/2. Just park it outside so that I can write square root of 45xy over 5. 1/2 just hangs out. 45 divided by 5 is 9 xy. We can take the square root of 9, so that's 1/2 times 3 square root of xy, which is 3/2 square root of xy. If you really wanted to, you could also write that as 3 square root of xy over 2. Again, you might see that, but those are the same answer. We've got a lot going on in this one. For part C, go ahead and write it as a single cube root. Cube root of 16x to the 5th y squared over 2xy to the negative 1. Cube root, 16 divided by 2 is 8. 5 here, 1 here, subtract, there's 4 left over. 2 here, 2 minus negative 1 is 2 plus 1 is y cubed. Now that that's simplified, now we can do cube root. Let me write that as cube root of 8 x cubed times x times y cubed. Cube root of 8 is 2. Cube root of x cubed is x. Cube root of y cubed is y. Square root of x. Okay. Try out the practice problems. Use those as a model. Condense this into 1. 40 x to the 5th over 2x is square root of 20. 5 take away 1 is x to the 4th. 20 is 4 times 5. Square root of 4 is 2. Square root of x to the 4th is x squared. 5 will stay under the radical. Again, for this next one, just be really careful with the 2 in the denominator. Just pop it out as a 1/2. Square root of 50xy over 2 square root of 2. Just make that 1/2. Square root of 50xy over 2 is 1/2 times square root of 50 divided by 2 is 25xy. Square root of 25 is 5. So the answer is 5/2 square root of xy. For the last problem. Cube root of 48x to the 7th y over cube root of 6xy to the -2. Now, what some students might do is try to simplify this and try to simplify this, which you're allowed to do, but you're going to get kind of a complex numerator denominator. The easiest way, I think, is go ahead and condense it into a single radical, then simplify. Let's see, 48 divided by 6 is 8. 7 here, take away 1, x to the 6. 1 here, take away -2. 1 minus -2 is 1 plus 2 is y cubed. Cube root of 8 is 2. Cube root of x to the 6 is x squared. Cube root of y cubed is y. Now look, our solution doesn't have a radical in it, and that can happen sometimes, and that's okay.